So here are my 6 data values: 25, 30, 35, 35, 40, and 45. So when we're finding standard deviation by hand, the first thing we need to do is to find the mean. We can't actually do anything until we find the mean. So to do that, we just need to add up all of these things and divide by the number we have. When we do that, we get that the mean of this data set is 35. The second thing we want to do is find what's called the deviations, which is what we call those xi minus x bars. Those distances from the mean are known as deviations. So that's our second step. I find it easiest to do this in a table, so I'm going to go ahead and write this down in a table. So here's the table. I put all of the x values, all of my actual data values, in one column, and on the right I'm going to subtract the mean. So first I have 25 minus 35, which would be negative 10. 30 minus 35 is negative 5. 35 minus 35 is 0. 40 minus 35 is 5. And finally, 45 minus 35 is 10. We can see that if we add up this column that we just made, it adds to 0. Just like we talked about previously, this column should always add to 0. And it is a good way to go ahead and check your work, to just see if this adds it to 0. So now let's talk about the next step. The next step would then be to square these values. In order to do that, I'm just going to form another column to this table to then square. Negative 10 squared would be 100. Negative 5 squared is 25. 0 squared is 0. 5 squared is 25. And 10 squared is 100. So now I've completed step 3, and I'm going to look at step 4, which would then be to actually add these values up. So I just need to add up this last column that I made. So 100 plus 25 plus 25 plus 100. That gives me 250. I ignored my zeros since they don't contribute anything to this sum, but normally if I would have had numbers there, I needed to make sure to add those as well. Step 4 is then to divide by n minus 1, because our formula for standard deviation is divide by n minus 1. Since this data set has 6 values, I'll need to divide by 5, since 6 minus 1 is 5. And that gets me 25. And at this point, I do have the variance. Dealing with variance is a lot more rare than dealing with standard deviation, but so far I have found the variance. And I just need one last step to find my standard deviation, which is to take the square root. And since the square root of 25 is 5, I now have that my standard deviation is 5. So as you can see, we did a lot of work to get here. Calculating standard deviation is not an easy task. Individually, if you look at each of the individual steps, we technically don't do anything that difficult. Finding the mean is easy. Step 2 is just a bunch of subtractions, and we should know how to subtract. Step 3 is just squaring values. We know how to do that. Step 4 is just adding up a bunch of numbers. 5 is a simple division, and then 6 is a square root. However, whenever it all gets combined together, it can get overwhelming and there is a lot of room for error. If you mess up on any one of these steps, it's going to carry throughout the whole problem. As a result of this, of it being so difficult to calculate, we're going to look at an alternative way as well. So here are my 6 data values: 2, 3, 3, 8, 10, 10. And this time, I'm actually going to use a calculator to help me. In particular, I'm going to use the GeoGebra graphing calculator. This is an app that you can get on any phone or tablet. In addition, they do have a web version, which you can find at just geogebra.com. And it's a great graphing calculator that has a lot of statistical functions. Here's what the GeoGebra graphing calculator looks like on my tablet. And I want to look at finding the standard deviation. We can see the keypad down here at the bottom. And at the top right of the keypad are these 3 dots that I'm going to click on. And it brings me up to this. This is a list of all of the functions and commands that this calculator is capable of, sorted by subject. Since we're studying statistics, we're going to scroll down until we see statistics and select that. And we have a lot of different commands here, and a lot of them we'll look at various times throughout the semester. But for now, we're going to go down to the S's. And this STDEV, that is our standard deviation. And STDEV is just a common calculator abbreviation for standard deviation. So we're going to select that. It's important to not select the one with the P, but we want the one without the P, just the STDEV. And after that, we just need to enter in our data points with commas between them. So our data points were 2, 3, 3, 8, 10, 10. And we can hit return. And we have that our standard deviation is about 3.74. So this is much, much easier for us to calculate standard deviation, and it's much more common to use calculators. Let's look at one more example, just to make sure we understand this. So once again, I'm going to click on these 3 dots at the top right. This time I have a couple of options to get to my standard deviation command. 1, it's up here in my recently used. 2, I can scroll back down to statistics, wrong one, to statistics and find it again. And then the third one, now that I actually know what this command is called, I can use this search function up here and start typing it in, and we see it come up. So any of those will be valid. This time I'm going to do a data set that has 3 5s, so 5, 5, 5, 6, 7, and 8. So this time my standard deviation is 1.26. Now that we have a little bit of ideas of how to find standard deviation, let's talk about what it actually tells us. So exactly what is it that standard deviation is calculating? Standard deviation is the variability about the mean. So what exactly that means? If we have a large standard deviation, it tells us that our data is really spread out, whereas a small standard deviation tells us it's really compact. Standard deviation is telling us about, on average, how far things are from the mean. So a large standard deviation says that things are really far away from the mean. It's kind of all spread out all over the place. And a small standard deviation says that everything's really compact and right on top of each other. And standard deviation is super useful in a lot of our statistics that we're going to deal with later on. And one final note about standard deviation. We talked previously about how if your data was symmetric, we prefer the mean, and if the data is skewed, we prefer the median. But it's actually more than that. If our data is skewed, we actually prefer both the median and the 5-number summary to give us a full picture. Whereas if our data is more symmetric, we prefer the mean and standard deviation to give us a better idea of the full picture. So how do we know if our data is symmetric or skewed in order to know which one of these to report? And the answer is graph the data. We talked about that first because that's the thing that we need to do first before we start these calculations.